Good evening. Today we are going to discuss about assignment 9 in machine learning, that is reinforcement learning basics. So in this assignment, we're going to learn all these concepts regarding reinforcement learning. Reinforcement learning is in learning paradigm in machine learning, like supervised and supervised. Reinforcement learning is also one of the type, and it is used for complex machine learning problems. And in this, we're going to discuss about agent, environment, action, state, observation, policy, and reward. So basically, what it is means there's a learning agent, which is our model. So this learning agent takes an input from the environment, the observations from the environment, and it takes an it does an action. So it does an action, and that action will give an output. That output is a reward or a punishment. So whether it is good or bad, there are feedback that would be given to the learning agent so that it will be learning on its own. It will learn on its own. So the environment is the like where the agent lives, the world where the agent lives, and action is the movement or other types of decisions taken by the agent. State is nothing but the snapshot of a particular movement, and observation is information gathered from the state of environment. From the environment, the agent gathers some information, that is an observation. So for this, we will use OpenAI Gym. We install uh, the necessary packages, and next we import the gym and import gymnasium as a gym. Then it is like this OpenAI gym, it contains many environments. So for learning reinforcement learning, we choose particular environments. In this, we have chosen two environments. One is mountain car. So this is a car. This is the mountain range, and the ultimate task of this uh, environment is the agent needs to get to the yellow pole. And next, this is the card pole. So we know about card pole, so we need to balance this card. So these are the two environments. So for that, we need to create the environment, that is mountain car environment and card pole environment. So using gym make function, and then we need to design actions and observations and reward for each reinforcement learning task. So for that, we need to reset the environment. So we need to reset the entire environment for the mountain car and the cart pool. So next, we are going to like give what are the actions, number of actions in mountain car and carpool, the 3 and 2. So we need to advance one step. We need to call the step function, and for that we'll be getting an output of observation and reward, terminated a boolean, like a boolean indicating episode is over or not, and truncated a boolean is indicating that whether it is ended or not. And we will be getting additional information as well. So next, mountain car environment we will be discussing about. Uh, for these, sorry, sample a random action for the action space of mountain car. So we're going to use random action as a variable, and mountain car environment dot action dot space dot sample, that gives a sample random action. And then we'll be taking all these observation, reward, and all we'll be getting all this variable data from dot step. Using the in the step, we'll be giving the random action as a variable. So we'll be so there are two actions, and observation would be this, and the reward is -1, truncated false, and terminated is also false. So episode is not done. So that's a random random example for the car. And the next here our exercise one start. We need to explore the cart pole environment. Perform a sequence of 10 actions in it. 5 actions to move right, followed by 5 actions to move left. So from above we know that there are two possible discriminations, action 0 and 1 in this environment. Yeah. So action sequence is right and left. So 5 to the right, 5 to the left. So we are initializing terminator as false. So until it is a true, terminator is true. Until the uh, environment is like a sorry, until the episode is done. So we are running this action sequence for front, sorry, right and left. So we'll be getting all the observations using the dot step function, and next we'll be printing all the for every input action we'll be taking the reward and we'll be taking the observation. So at the end it would be so you can see after all the observations we can see the terminated is true, and then we'll be getting uh, like instead of giving a random action, the agent will be getting a trained policy using the observations as input. So the reinforcement learning, the agent will take the observations and the previous reward as an input so that it perform the next action. So let's examine the observation space. So we'll be initializing the observation space for the card pole and mountain. So card pole observations, this is the shape, and for the mountain card, this is the shape. So like the observation space has limits on high, how low or how high or low the values can be, and so these are the observation limits of card pole and observation limits of mountain car, maximum and minimum. And so these are the observation limits. Next, for the exercise 2, we're going to explore the Acrobat environment. So how many functions can you take? What are they? Reset the environment. What are the observations and higher limits and all? Sample errors, random function space in the environment. Uh, what is the reward we are getting? This all we are going to find. So for the Acrobat environment, we are initializing using gym.make Acrobat version 1, and then we'll be printing the number of actions using .n, and then initial observation we need to set the Acrobat environment using .reset, and what is the shape, size, shape, and limits, and the sample random function using sample, and then we are going to find the what is the reward. So so we can see since reinforcement learning agent goal is to maximize the cumulative reward, the feedback signal is very much important. That is a reward, which is very much important to perform the next action. So, for this assignment, we will not delve deep into the training as an agent using baseline 3. So, we will just will not get deep into the reinforcement learning. We just need to learn basics using OpenAI environments and all. So these are the we're going to initialize the stable business line baselines using Git, and this is the code that would be creating the baseline function, baseline code, and then we need to define an agent for the environment. For hardcore environment, we will train policies that are approximated by multi-layered to 20,000 time steps for Cartful environment. So these are the 20,000 steps, and the callback is given as reward callback. So that would be we'll be getting from for every 2,000 episodes we are getting a reward. So after completing every step for up to 20,000, uh, after completing every like it trains it for 20,000 steps, and then we are going to using the matplotlib like reward that was obtained. So what is the reward that was obtained? So we'll be plotting the reward data using NumPy and matplotlib. So this is the data that we got, the reward data that we got, and reward data for 20,000 steps, and this is the like reward that we got. This is the learning curve, and next we see evaluate training agent, observe how good our agent has become after training. Mean reward over a 100 episodes. So we'll be giving reward over for every 100 episodes. So this is the for every 100 episodes we'll be getting a reward. Carpool environment. So main reward over 100 episodes of training policy is 500. So next this is the bonus, like we just need to train our we have trained our carpool environment, and we just need to record the video for like how it is working. So this is the little video. So this goes like 5 steps forward and 5 steps backward, and it will balance its goal. So for every each and every episodes, it tries to balance. So this is the performance of the training agent. Sorry, for the reinforcement learning agent. So basically in this assignment, we have discussed about how useful is the report and what is the environment and how the observations has been, how the parameters like observation, action, and the reward has been done. So this is the end of the assignment. Thank you.